like radicals, have the same index, so the same cube root, square root, fourth root, and the same radicand. So the same thing underneath the radical sign. So add or subtract if possible. We can add these two together because they both have root xy. So this is 10xy. These I can't break down any further, and they have different radicands. So this is not possible. And then 6 root 10 minus 4 root 10 is 2 root 10s. They're like terms. Sometimes you have to simplify before you add or subtract. So what I'm going to do is I'm going to break down root 20. So root 20 is 2 root 5 minus the square root of 45 is 3 root 5. And then the square root of 80 is 4 root 5. So these numbers stay where they are, and then they're going to be multiplied by whatever it simplifies to. So this is going to be 6 root 5s minus 3 root 5s plus 16 root 5s. And now you simplify these. So 6 minus 3 plus 16 is 19 root 5s. Same with over here. I'm going to reduce all of these. So root 50 is 5 root 2 plus 3 root 32 is going to be 4 root 2. And 5 root 18 is 3 root 2 because 18 is 3 root 2. So now you have 5 root 2s plus 12 root 2s minus 15 root 2s, and now they're all like terms. So 17 minus 15 is 2 root 2s. You can do the same thing with cube roots too. So if I break down the cube root of 68 or 128, the cube root of 64 is 4. So it's 4 cube root 2 minus the cube root of 27 is 3, and 27 times 2 is 54. So that's going to be 3 cube root 2. So I look at the coefficients, and it's 3 root 2. And then down here, you can use FOIL. So this didn't copy very well, but I'm going to FOIL this one just to show you. So I write them out. They're already written out. Okay, so to do FOIL, you're going to do 7 times 5 is 35 minus 7 root 3s. I always write the radical afterwards. Plus 10 root 3s. And then minus 2 times root 3 times root 3. So root 3 times root 3 is 3. So now I simplify. I got 35 plus 3 root 3s minus 6. So I'm going to write the rational part first and write the irrational part second. You cannot combine these two because they're not like terms. Now I'm going to show an example where it's squared. So if it's squared, you need to write this out twice. So it's root 3 plus root 5 times the quantity root 3 plus root 5. So root 3 times root 3 is 3. Root 3 times root 5 is root 15. The middle term is also going to be root 15. And the last term is root 5 times root 5, which is 5. So 3 plus 5 is 8. Root 15 plus root 15 is 2 root 15s. So if you have to square it, make sure you write it out twice and then use first outside, inside, last. Use the distributive property. Conjugates are expressions that differ only in the sign of the second terms, So root A plus root B, the conjugate is root A minus root B. And when you multiply conjugates, what happens is the outside terms and inside terms, so if you think of FOIL, first, outside, inside, last, the outside terms and the inside terms will just cancel out because you'll have plus, you'll have positive AB, and you'll have negative AB, and they'll cancel out. So when you have conjugates, you only have to do the first terms and the second terms. So in this one, I'm just going to multiply the first terms because I recognize that they're conjugates, and then I multiply the second terms. And so now I just get the number 2. So conjugates are nice because the irrational part drops off. So I multiply the first terms, and then I multiply the last terms. And I get 3. That's a shortcut. You could FOIL it out if you want, and then you get the same answer. Sometimes you need to rationalize the denominator of a fraction when the denominator is a binomial radical expression. So we're going to multiply by the conjugate, this is why this comes into play, of the denominator. So the conjugate of 4 plus root 3 is 4 minus root 3. Technically, we're multiplying this fraction by a value of 1, but it's just changing the looks of it, simplifying it because it's a radical in the denominator. So I'm going to use FOIL on the top and do 8 minus 2 root 3s minus 4 root 3s and then plus 3. My denominator, remember, these are conjugates, so all I have to do is do 4 times 4, which is 16, and then root 3 times root 3 is 3. So my numerator looks like 8 plus 3, which is 11, and my denominator is minus 6 root 3. All over 6 minus 3 is 13. So at the end you want to see, can you reduce this? Is there something that you could divide these by and you can't? So you can just leave it as 11 minus 6 root 3 over 13. If you could reduce them, I would break it up. And then over here, you're going to multiply the conjugate of 10 minus root 7, which is 10 plus root 7. And I'm going to FOIL the top, so it's going to be 30 plus 3 root 7 minus 2 root 70 minus 2 times 7, so minus 14, all over, and these are conjugates on the bottom, so it's just going to be a times a, which is 100. It's going to be a negative 7. So now I combine 30 minus 14 is 16. And then I want to make sure that I can't break down root 70 any further. Are there any doubles in there? No, there's not. So I write 16 plus 3 root 7, plus negative 2 root 70, all over 93. And I really can't reduce these. I could reduce 3 over 93, but if more reduced, then I would break it down. And then the last one, the conjugate of 4 minus root 15 is 4 plus root 15. So the top part's going to be 24 plus 6 root 15 plus 4 root 15s plus 15. In my denominator, I'm just going to do a times a and b times b, so it's 16 minus 15. So if I simplify, I'm going to have 39 plus 10 root 15s all over 1, so I can just write it like this.